Welcome ladies and gents. Right, let's jump straight into it. Talk about this SV engine build and all the bullshit that's on the internet about it. A lot of it's just a waste of time. And that's the exhaust I made for it. Made it from stainless. Sounds awesome. Okay. Let's start with let's start with the gear position sensor, the one that's in the motor. Now the normal TRE mode on the red wire, you'll put two 6.8 kilo ohm resistors. It's small resistors like this. It's just it limits the flow of electricity, or it changes the current. It will say 2 volt, it will give you 4 volt. That's all it does. Now, what I find the problem with this, especially on this SV, was that with this normal TRE mode, if you can go look at dyno charts, and then you'll see 4th and 5th at 4 number 5 gear, you'll see it goes down on the dyno, and this is what's causing it, definitely. I could feel it when I'm riding the bike. The power goes away. And then with this mode, with the first one that I did, I put 15 kilo ohm resistors on all of them. I removed the original ones and I made them all 15. And as soon as you hit the accelerator, you can hear the throttle bodies. It's extremely loud, and there's a problem with that also. The problem is like when you build a racing engine and the cam overlap's not right, and you get that intake sound, it means the fuel is fluttering. Then what that 15 kilo ohms does, it opens the butterfly. Say you hit the accelerator full, the butterfly is 90 degrees, and then that 15 kilo ohm resistor, it opens the STV valve that sits above the throttle body. It opens it also 90 degrees, and then what happens is when the overlap of the cams is overlapping, the fuel actually flutters up into the airbox, and this is not holding, making a vacuum so the fuel can go into the motor. So that's what's happening. That's why the power is going away when you on a dyno and you see on number 4 or 5 the power is going down. That's what's happening. Then what I did is I soldered new wires on. I made a cable 1/2 meter long. I took it up, I put it in a black box, put that resistors in that box. Then I made first gear 2.3 ohms, kilo ohms. The neutral one should be 1 kilo ohm. If you change that one, the bike runs like shit. Then number 2, 3 and 4 gears, I made those 4.3 kilo ohms. And 5 and 6, usually the 5 has a 12 kilo ohm and 6 has a 15 kilo ohm, but it seems it's not working too good. So I made it 7.4, and this combination on that Jeep gear sensor, it works really sharp. Alright, then what I had to do on that bike of mine, I went open-minded on this thing. I tried everything. I ran bearings twice on the motor. I had to machine the crank in the lathe down to 47 on the mains. I had to cut the big ends 10 thou, and that's also something you shouldn't try yourself. I have the equipment to do it. Even to make bearings, it's not the easy thing. Here's all the drawings for it. All the drawings and stuff I made. This is the mains I made. I made them 25 wide. Put extra holes in it. The crank, I machined the crank pin was 47.75. So I tried everything. Ran the bearings twice. I pulled that motor about 6 times already in December. So not worth it. Another thing is the cams. What they do is they take the idler gear of the cam and they move it 1 teeth forward, and then that advances the cams. The bike actually runs worse. I struggled to get 10,000. After 8,000 the bike didn't want to make power anymore. So I went back, I put this gear back on its original position, cams back on the original marks. Then I used this board that I made, and I put this thing in, and the bike's making power. And I still run standard sprocket 1740, and if you hit that accelerator, the front wheel's coming up. So I got my about 8 to 10 horsepower, but I worked hard for that. I never worked so hard for 10 horsepower in my life. I don't think I'll do it again. Alright. I even went as far as I have management systems like this here. And then I thought, okay, now let me just install a management system. Then I thought, okay, at the moment it's not worth it because I'm still testing all of this stuff. But with this management, I don't need to worry about all this and air sensors and map sensors or nothing. I can run everything from this box. I even went as far as planning to making my own management system. Get a processor, timing manipulator, and sensors and all of that. Then I thought, okay, to write all the codes for this, to make a system, it's just too much work. It's going to take me at least 2 months. I don't want to spend 2 months working on a system. I'd rather buy one of these. And then what I did on the air sensors and map sensors, I used resistors like this. So you can change the value of the the sensor, and it will make the bike richer or leaner, and this will actually move timing. And that system, that Suzuki EFI, doesn't like these things. The bike will throw you off. So that was also another waste of time. And another thing is, they say on this gear position sensor, the original one, this one, it retards timing with the management system. That's all bullshit. I cannot find anywhere. I tested everything. I could not find that EFI system from the Suzuki that it retards timing 17 degrees. I could not find something like that. It retards only the STV by 17 degrees. That's what it's doing. It doesn't retard timing. So that was a whole lot of bullshit. I was chasing my tail the whole December for nothing. And I had to do all this work in between my other work. So tomorrow we'll take this guy on the road trip quickly. I'm going to Yamaha. I have to order parts for that Yamaha. And let me show you. I even installed the oil gauge here underneath so I can keep an eye on the oil pressure, because I was running bearings because I made the compression way too high. So we'll give it a go tomorrow. Thanks for watching, guys. We'll see how it runs. I'm gonna take a scenic route past the game parks. Thanks for watching.